You know, guys, listen, we're doing that little boy group back there that constantly does this little baby stuff. And really, you tie my hands, because the way to deal with it is just separate them. And then it stops all the time. So you can either get it to stop without my getting involved, or you can make me get involved. But one way or another, it's gonna stop. Clear?
Yeah.
Okay. All right, kill lights, please. Yeah, Fernelise asked a really good question. He says, is that supposed to be negative 1/3? I do all my lesson planning on my personal computer, and usually I save it as a PDF file, and it usually copies over fine. You see, the problem is this other computer over here, the school computer, that computer is much older, and the software on it is much older. So the old software doesn't always recognize what the new software does. So I have to send it a PDF file. But every once in a while, it tries to copy over in the old program, and it doesn't transfer well enough. When that happens, I have to get a little creative, and number one is an example of that. What this really says is y equals negative 1/3 x minus 5. And then it says in the function, what's the value of y if the input is 12? Now, input is what letter, x or y? X, good. So I'm going to put a 12 in for x. Now, you guys are now allowed to use the calculators, and the only thing I ask is, if you use the calculators, and I see a lot of you with them, when you put them back, don't just throw them on the counter over there. Put them back in the slots nice and neat. Put the cover back on the right way, and then put it in there. If you don't have a calculator yet, don't bother getting it for today. It's not like a really mandatory thing. But in the future, know that. Okay, if you don't have a calculator, this is not difficult to do in your head. Get your hands on your own desk, right? Do the division first. 3 goes into 12 how many times?
4 times.
4. Negative 1 times 4 is negative 4 minus 5. And we did questions like this earlier in the year where we said, look at this as 4 negatives and 5 more negatives. So what is that altogether? 9 negatives. So I get negative 9. Okay? The next one says, which of these two graphs is a function? I don't care what you drew for your graph. I just care that if you do the vertical line test, it only touches once. It's not allowed to touch twice or more. Okay? Which of these two ordered pairs is a function? Which one's a function, A or B? B. Why isn't A a function? That's right. Yeah, the domain, the x repeats the same number. 3 is twice with 2 different images, 12 and 15. The next one's kind of like a tricky question, and to be 100% honest with you, I think I know the right answer, but the spirit of it is being really, God bless, it's being really picky and really wrong. Similar triangles are exactly the same size and shape. Always, sometimes, or never true. The spirit is never. Congruent triangles are exactly the same size and shape. But the truth is that if you're congruent, you're also similar in the sense that you are the same shape and the sides are proportional. It's just 1 to 1. They're the same exact size. So if you put down sometimes and explained it that way, I could accept that as an answer too. Okay, 2 triangles are similar. The sides of the first triangle are 7, 9, and 11, and the smallest side of the second triangle is 21. Find the perimeter of the second side. Now this is a pretty challenging question. They used to give this on the 10th grade math regions all the time. But it's not overly hard. Now, as soon as I start reading about similar triangles and lengths of sides and so on and so forth, I start thinking, little is too big as, little is too big, said in my best British voice. The reason I say it in a British voice is because it just sounds British. Little is too big. There's this singer named Mick Jagger. He's the singer for the Rolling Stones. And he has a very famous quote about people like me. He said, we get good at as we get older.
That's the biggest mouth ever.
We get good at as we get older.
Oh yeah. Much gooder.
Yep, much gooder it is. Okay, now, here's the sides of one triangle, 7, 9, and 11. It says the smallest side of a second triangle is 21. So what side matches up with the 21? Is it the 7, 9, or the 11?
7.
The 7. because it says the what? The smallest side. Which is the smallest side? 7. So 7 is to 21 as. Now, here, there's a couple of different ways we can do this. One way that we can do this is to find each side individually. Watch. 7, 9, 11, 21, x, y. And I could then find the x, I could then find the y, and then I could add them all up to get the perimeter. That's one way to do it. Okay? Let's do it that way. Hey, 7 is to 21. What do you notice about that? Multiply by 3. So then if this is 9, what would 9 times 3 be? 27. And then 11 times 3 would be? So now what's the perimeter? 27 and 33 adds up to 60, and 21 makes 81. Okay? So that's kind of a shortcut way to do that. When you see the ratio is 1 to 3, just multiply it by 3. Okay? We'll do plenty of others where we use the proportion in a couple of minutes. Any questions? All right. Now, graph. What I need you to do is to take triangle ABC and mark these coordinates. A, B, C, draw them on the graph, and then do what it says there for D. Because if I put it to the edge, it might not fit, but by moving it over a little bit, it fits nice on there. Okay, go ahead, do that. No, you reversed them. You did 4, 3, and 4, 0. Or 0, 4 rather than 4, 0. Okay. Now, I've seen about 5 papers where kids reverse the coordinates. Look, any coordinate is x-axis. So when I read 4, 3, I go to 4 on the x-axis and then up 3 to the y, and that's where point B is. Some people did it the opposite way. And then 4, 0, 4, and 0. Some people put it up here. That's backwards. Okay. Now, the next thing it says to do is extend triangle ABC into triangle ADE, where D becomes H6. 4, 8, 6. So I extend it until I hit 8, 6. And then this way, I'm going to extend it until I hit 8, 0. Now, the little blue triangle grows into the big red triangle. Now, this is an example of The word is dilation. Dilation. Everybody say dilation.
Dilation.
No, I heard some people say dilation. It's not dilation. There's no D-I-A.
Dilation.
It's dilation.
Dilation.
Dilation. Stop. Now, what this should sound like, or a situation that you should recognize this from, is when we do a thing called dilating your pupils. You know how your eyes, your pupils in your eyes can get bigger, get smaller? Now, sometimes you get that on an eye, if you go to an eye doctor, they'll test it for you. My wife went to an eye doctor yesterday, and he dilated her pupils. They put the stuff in your eyes, and then they turn the light on and they look in there. But when I was in school, we actually did a pretty cool test that I used to be able to do, but I can't do it in here anymore, because if I pull the shades down in here, the shades kind of have holes in them, so they let light in. So it doesn't really get super dark in the room. But it used to be such that you could turn the lights off and you could pull these shades down, and it would get pretty dark in the room.
Are they blackout shades?
And then when I was in high school, we would do this, and my teacher would, he said, listen, turn and face the person next to you and get your faces like this close to each other. And he'd say, just, would you stop already? Seriously, enough. You know what? I've had enough. Michael, switch with Sam. Eric, switch with Forrester.
What?
Switch seats with Eric. Lancaster, switch with Brendan. Dennis, go move over where Jalea was. You know, you guys just couldn't handle it without turning it into baby games and little giggle crap. Now, no, Isaac, I didn't move you there. Go back in the seat you were in. The whole point is to keep you away from each other. Now, when we were in school, the room would be almost black. And the teacher would tell you to get about 6 inches, maybe less than a foot, away from the person next to you. And he'd say, stare into each other's eyes. And he would keep the lights off for like 2 minutes. And then he would turn the lights on. And you would watch every person's pupils go like, and shrink down. And you've actually experienced this, where maybe you've been in the house, like after a snowstorm, and then the bright sun comes out with the snow, and you walk outside the door and you're like, oh man! Yeah, well what happens is, your pupils adjust. As there's more and more light out there, your pupil gets smaller and smaller, because you don't need as much light to see. But when it gets dark out, your pupils open wide. The ultimate example of this is a cat. You ever see the cat's eyes, how they're really thin when it's bright out, but then at night they get these big saucer eyes, or an owl?
Or when they're gonna attack them.
Now,
Like a shark.
now, what has happened here is the same thing. The blue triangle is like your pupil really tight, and then it expands to let more light in with the red triangle. So, now, yes, we can do little is to big as little is to big, but there's also a sense of what's going on in here. You see, the blue triangle is being transformed, here's the key word, into the red triangle. Now, I'm sure you've heard of the movie Transformers.
Yeah.
Okay. Now, for the first time ever in the last class, I mentioned the movie, and I got a strange response, because they said, oh yeah, there's Bumblebee and Olympus, something or other, Optimus, and then they went up with these other names, and Megatron, and I'm sitting there listening, and every year that I've ever talked about Transformers, all the boys in the class were like, Megan Fox.
Oh,
And I didn't hear a single boy say Megan Fox, and I was like, that's all right. This is usually, well, she was the pretty long-haired girl that was in the movie. And usually, now you know why I usually hear the guys say Megan Fox, and apparently that's just not the thing anymore. Showing my age again. Now, what a transformer does, yeah, it transforms. Transform is to change. So they would start out as like a car and change into this super big robot. Now, if we start a triangle, we're gonna stay a triangle, all right? We're not gonna change from a triangle to say a hexagon or something like that.
That would be fun.
But the blue triangle, under a dilation, and dilation is the only transformation that changes size, turns into the red triangle. Now, when you want to think about how much bigger it gets, let's do a little bit of analysis here. How far is it from here to here? 4. Now, you can either look at the coordinates, 0, 0, 4, 0, or you can count. 1, 2, 3, 4. How far is it from here to here? 8. 5, 6, 7, 8. Now, the next question says, if this distance is 5, how long is that? 10. Look, if 4 grows into 8, and dilation is always by multiplication, what did you have to multiply the 4 by?
3.
4 times 3 is 8. 2, good. So then if I do 5 times 2, what do I get? 10. Now we can also set that up if I call the x and say, little is too big as little is too big. So I could say 4 is to 8, 4, 8, as 5 is to x. Now, cross multiplying always works. Cross multiplying is a beautiful thing. But sometimes there's quicker ways. 4 times what gets you 8? 2. So 5 times 2 is 10. You can do it either way. Okay? Any questions? All right. So that's what a dilation does. What kind of transformation is that? Dilation. Very good. Okay. Figure out n. As soon as I see this, I start thinking, little is too big as little is too big. That's supposed to be a very annoying song. It sticks in your head. It's right up there with Frere Jacques.
Oh God, no, you just brought that back.
Jacques. Now, okay. Now, or the classic John Jacob Jingleheimer Schmidt. Never heard that one? His name is your name too. Never heard that? Okay. Now, sit up. Little is to big, as little is to big. I like to look for the sides that are both numbers first. 11 is to 33, as n is to 27. Little is to big, 11, 33, little triangle, n is the big triangle, 27. The sides that pair up. Now listen, here's the thing. If you take a look at this, you could cross multiply. Cross multiplying always works. What did I just say? It always works. But it's not always the quickest way. Sometimes you can just look for relationships. 11 times 1 will get you 33. So therefore, what times 3 is 27? 9. And I think that's quicker than using your calculator. But you can if you want to. Okay? Now, try this one. Friendly, 7 good. You're not even on the right page. You know, what I like so much about seeing little is to big on your paper is that it's setting up the proper mindset for thinking. In wrestling, in stance, you want your feet equally apart, slightly wider than your shoulders, you want your elbows in, you want your thumbs up. If you're in this position and you're moving, you're in good shape, you're in good position. Very, very hard to take down. As soon as you get out of that stance, you're done. If you're wrestling a kid who's any good. So you gotta learn to stay in the proper position. This sets you up for proper position. Little one is the big one. I look for those sides that match up right away. 2 is to 4. As little one is to the big one, what goes on the other side? X is to 9. Now, sometimes I can look at it like before and say, oh look, 4 is twice as big. But the problem is with normal numbers, we don't have a whole number that times 2 equals 9. You may realize it's 4.5. If you do, that's excellent. But if not, just cross multiply, because cross multiplying always works. 4x equals 18, divide by 4, x is 4.5. And there's my answer, okay? Now, here's the cool thing. This algebra topic is brand new, and it's very unlike what we've been doing so far this year. That's about as complicated as the algebra gets in the whole chapter. So, I think you can do really well with it, and some people are really comfortable with geometry. They like it a lot more than they do with algebra. Okay? She knows you didn't forge it.
It looks like I can do that.
You know who you remind me of when I talk to you? Your voice. Not your looks, your voice.
Yeah.
Miss Kennedy.
Everybody says that. Oh my god. Like, all my friends, you and Miss Kennedy sound alike and smile alike.